are going to see the various explanation of photoelectric effect using Einstein's theory of photoelectric effect. So we have already seen what is Einstein's theory of photoelectric effect, and we have also read the equation, right? So previous to that we have also studied what is the photoelectric effect, what are the various conclusions that we, or the observation that we see in photoelectric effect. So now let's see, after knowing the Einstein's theory of photoelectric effect, now let's see how this particular theory is able to explain various observations and various other conclusions of photoelectric effect. So from Einstein's theory we have seen this particular equation which says that the maximum kinetic energy of the photoelectrons that are coming out is h nu minus phi. Here phi is the work function of the material. So let's take phi as the minimum work function for a particular the minimum energy for a particular metal for the electrons to come out, that we have named it as phi naught, suppose. So this is the work function. So and this particular is the kinetic energy equation, or the equation of Einstein, equation given by Einstein for the explanation of photoelectric effect. So as we know, when the photoelectric effect is happening, the electrons are coming out. At that particular time, this maximum kinetic energy can never be negative, right? So generally kinetic energy cannot be negative. So it is always positive. So since kinetic energy K max is always positive, we can write K max is always greater than 0 because it's always positive. So it is always greater than 0. So since it is greater than 0, therefore from this equation we can write h nu minus phi naught is actually greater than 0, right? So from here we can write h nu should be greater than phi naught for the photoelectric effect to occur. So suppose this is the surface, this is the radiation that is falling, and therefore this electron is coming out. So for this wave, or for this light that is falling, if the h nu is the energy of this light, then these electrons are coming out, and this h nu has to be greater than the phi naught, the work function of this particular material. So always the incident light should have the energy h nu which is more than the work function of that particular material. And see here, h is the constant, therefore we need to have enough of frequency. So here the deciding factor, since this is constant, so nu is the factor that decides whether the photoelectricity or the photoelectric effect that would happen or not. So now suppose photoelectric effect to occur, always this h nu factor has to be greater than the work function. Now suppose at a particular frequency, which is just the frequency to photoelectric effect to just occur, it means suppose that is the frequency which we call it as mu naught, which is exactly equal to the phi naught. So whatever is the work function of that material, we are taking exactly same energy of light which has h nu naught effect. So it means that at this particular frequency the electron would just be able to come out, but it may not have any kinetic energy to move out, not enough sufficient, but with this particular energy it is just be able to come out, and this frequency, as we have already known, is called the threshold frequency. So the frequency of light, of the incident light, which just allow the electron to come out from the various forces, that is capturing it in the surface. So that we find it in from the Einstein's concept or Einstein's theory of work function, and this is threshold frequency that we have seen in our experimental study of the photoelectric effect. And this threshold frequency into Planck's concept is nothing but the work function that is given in Einstein's theory. So if we just substitute it in this equation, we can write the K max is equal to h nu minus phi naught, or this is equal to h nu into h nu naught, which is the threshold frequency equation, and therefore we can write nu minus nu naught. So the maximum kinetic energy with which the electrons would come out is given by this particular equation, where nu is the frequency of the incident light and nu naught is the threshold frequency for the electron to come out at that particular material, right? So here the Einstein's theory is able to explain the concept of threshold frequency that we have seen or that we have talked about in the previous experimental studies of photoelectric effect. Now coming to the dependency of the maximum kinetic energy. So in our studies we have seen that the kinetic energy of the photoelectrons depends on the frequency, but it doesn't depend on the intensity of light. So whichever light radiation it is falling, that radiation's frequency decides the kinetic energy of the electron. Even if you have for the same frequency of light, even if you have increased the intensity, increase the intensity in the sense you have now sending more number of photons per unit area per unit time. So even if more number of photons are sent with higher intensity of the same frequency light, then the kinetic energy would not change because the frequency is same. So the kinetic energy of the ejected photoelectrons does not depend on the intensity, but it depends on the frequency of light. This thing we have already studied in the experimental study, but now this equation and this study is proving that from Einstein's theory that the maximum kinetic energy depends only on the frequency. It doesn't have any effect on from the intensity of light. Next coming, that intensity is proportional to the photoelectric current. It means that if intensity of the light increases, suppose if as we know the intensity of the light is when it increases, it means that number of photons per unit area per time would increase. So when the light is falling for the same frequency, if I change the intensity, it means that now more number of photons per unit area and per unit time, more number of photons are able to have collision with more number of electrons. So if there are more number of photons are colliding with more number of electrons, therefore more number of electrons are able to come out, and therefore we are getting more number of photoelectrons coming out, which is increasing the photoelectricity. Since the more number of electrons come out, then the photoelectricity is also increased, and that's why we are able to see that intensity is proportional to photoelectric current. So as the intensity of the incident light increases, the current, photoelectric current increases. So this also gets explained by Einstein's theory. Next coming to the fact that this phenomena, this whole photoelectric effect is very instantaneous. It doesn't take time. As we have seen that had we tried to explain it with wave theory of light, it would take around few or several hours to several days for electrons to just come out. But here we see that things are happening instantaneously, and wave theory cannot explain that fact. So here Einstein theory says that since the photons are colliding with electrons, so it is a collision that is occurring, and due to this collision there is complete transfer of energy from photon to the electron, and thereby the electrons are coming out, and this whole process is very instantaneous. So since it is the collision that is occurring between photon and the electron, therefore the whole process is instantaneous, which is again explained by Einstein's theory of photoelectricity. And thus we can see that all the conclusions about all the observations that we have actually learned in the study of photoelectric effect, or the experimental study of the effect, various observations that we have taken, all those observations are getting kind of explained by the Einstein's theory of photoelectric effect. And therefore the Einstein's theory of photoelectric effect is the most what we say that most effective and the most important way of explaining the photoelectric effect.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.